The question is find the sum of the terms up to infinity. Cot inverse of 1 square plus 3 by 4 plus cot inverse of 2 square plus 3 by 4 plus cot inverse of 3 square plus 3 by 4 plus likewise up to infinity. The options are A pi by 2, B tan inverse 2, C tan inverse root 3 and D not means none of this. I am writing a shortcut case. So for this problem I will not convert into tan inverse formula. By using the cot inverse formula only I will write it. Okay. Now we know that cot inverse x minus cot inverse y is equal to cot inverse of yx plus 1 divided by y minus x. Here I will write y first, then x, yx plus 1 divided by y minus x. Here from the bracket term, here only I will consider bracket 1 square plus 3 by 4 plus 2 square plus 3 by 4 comma 3 square plus 3 by 4. Here 3 by 4 likewise up to. Here 3 by 4 is same. Here 1 square 2 square it is changing. So the general term I will write GT or general term is equal to 1 n square or r square plus 3 by 4. See here this bracket term only I will simplify it, r square plus 3 by 4. See here r square plus 3 by 4 can be written as 1 minus 1 by 4. 3 by 4 can be written as 3 by 4 is equal to 1 minus 1 by 4 or 1 by 4 plus 3 by 4 is equal to 1. Okay, is equal to r square minus 1 by 4 can be written as 1 by 2 square plus 1. So this will be a square minus b square form, r plus 1 by 2 into r minus 1 by 2 plus 1. I will write like this. Okay. Can I write like this now? This I will consider as y, this I will consider now. Cot inverse of r square plus general term 3 by 4. It can be written as cot inverse of. See, carefully observe it. R plus 1 by 2, R minus 1 by 2 plus 1. Okay, denominator is 1. See here, numerator is this term and denominator is 1. See, carefully observe that. First I will write R plus 1 by 2 minus R minus 1 by 2. So denominator 1. Denominator 1 can be written as r plus 1 by 2 minus r minus 1 by 2. This r cancel, 1 by 2 plus 1 by 2 is equal to 1. Cot inverse r square plus 3 by 4 can be written as cot inverse of r plus 1 by 2 r minus 1 by 2 plus 1 divided by, if nothing is there, 1 will be in the denominator. 1 can be written as like this. Difference of these two terms. In the numerator the product xy, yx is there. There are difference, I am writing it. This is equal to, this can be written as cot inverse of r first x term minus 1 by 2 minus cot inverse of r plus 1 by 2. This is x, this is y. Here x will come, here will 1 come. I am continuing on the next page. I will continue this on this next page. Okay. We need up to infinity. Therefore, sigma of r is equal to 1 is to infinity. First I will take n, later on I will shift to infinity. 1 is to n. Cot inverse of r minus 1 by 2. In the textbook they have written directly answer, but how to convert to, first we have to in the cot inverse of r plus 1 by 2. If in the board exam he asked, step by step we have to do it. Is equal to, First r is equal to 1 you substitute. If you substitute r is equal to 1, then cot inverse of 1 minus 1 by 2 is 1 by 2. Cot inverse of 1 by 2 we will get here. Minus 1 plus 1 by 2, cot inverse of 3 by 2 we will get. For r is equal to 1, here I am writing. For r is equal to 2, cot inverse of 3 by 2. 2 minus 1 by 2 is 3 by 2. Cot inverse of 5 by 2. Likewise, we shift cot inverse of for 3. This is for r is equal to 1. This is for r is equal to 3. R is equal to 2. R is equal to 3. Cot inverse of 5 by 2 minus cot inverse of 7 by 2. Likewise, up to r is equal to n I will substitute. For r is equal to n, cot inverse of n minus 1 by 2 minus cot inverse of n plus 1 by 2. See here all are plus here. See this term cancel. This will cancel. Likewise, the first term will remain as it is and the last term will remain as it is. Okay. This can be written as sigma of r is equal to 1 is to n. I am writing in detail. Cot inverse of r square plus 3 by 4 is equal to r is equal to 1 is to n. Cot inverse of r minus 1 by 2 minus cot inverse of r plus 1 by 2 is equal to cot inverse of 1 by 2 minus cot inverse of n plus 1 by 2 up to for r is equal to n. But we need infinity. If up to n he asks, you have to write. Therefore, limit n tends to infinity. N tends to infinity. Cot inverse of, this is a cot inverse of 1 by 2 minus cot inverse of n plus 1 by 2 is equal to cot inverse 1 by 2 minus cot inverse of infinity. See here, infinity plus 1 by 2 is again infinity only. I am writing directly as infinity. N infinity plus 1 by 2, again infinity only. Cot inverse of 1 by 2. I can write cot inverse 1 by 2 is equal to tan inverse of 2. Cot inverse of infinity is 0. So the final answer is tan inverse 2. The option B is correct. Tan inverse 2. Okay. See here, I am converting it to, I am not taking tan inverse or formula. If you take cot inverse, if you practice this, you can directly save the time by not converting to tan inverse function. Okay, now I will stop it.